Hey everyone, we're going to do 8.2 right now. So I got this up starting at the homework. It says the right trig function as a fraction and then as a decimal round to the nearest hundredth. Okay, sure. The first thing I want to do actually is check my calculator, make sure it's set right. So we can do the test of tan 45 and it should be 1 and it's not on this case. So this was because it's set on radians. I need it on degrees. So if you can find the setting, it's not going to be exactly the same, but the idea is that tan 45 should give you 1. Now your calculator, is set up to do this. We don't need this in this case or for the next couple problems, but it's good at the beginning to look at. All right. So now which ratio represented as a fraction? Okay, got it. We do that. So sine of c. So we're looking at c as our reference angle over here. And then sine is, again, we can just put this here if we need to. Again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, so katoa. So we have our sine, so that is our opposite. So that's 4 over hypotenuse is 5. So it looks like we have 4/5. And again, if we want to represent it as a decimal, 4/5 we can just do is 0.80. It said hundredth, so that's fine. All right, cosine of A. So cosine is adjacent over hypotenuse. So that's going to be adjacent 4 over hypotenuse 5. So that actually is going to be the same thing. Cosine of one angle is going to be the same thing as sine as the other angle in the same triangle. So 0.80 is fine. Cosine of C. So cosine is going to be adjacent, which is 3. This is from this angle, C. Adjacent over hypotenuse. So that's going to be 3 over 5. Or just, oops, I was going to write 0.6, but instead I did bad. All right, so 3 over 5, which equals 0.6. You can put 60 is fine. All right, sine of A. So now we're looking at, again, from angle A up here. Opposite is 3 over adjacent, hypotenuse, which is 5. So that, again, is 0.60. And again, cosine of 1 is the same as sine as the other. So that's good to know. Tan of A, so that's going to be opposite over adjacent. That's 3 over 4, which is, of course, is 0.75. And then tan C, well, that's going to be opposite over adjacent, so that's going to be 4 over 3, which is actually just 1.33 when we round. Now, if you'll notice 3 over 4 and 4 over 3, tan of one angle is going to be the reciprocal of tan of the other angle. So just as a fun fact there. All right, so then it says use each special right triangle to write each trig function. What I'm not going to do is put cosine 60 in my calculator, right? If I do that, clear it off here, we have cosine 60, it's going to give us this value, and we're like 0.5. We can handle 0.5, right? But if I did tan 30, we end up with a crazy decimal here. That's going to be weird. So we can do it exact way. So we can actually just, looks like we're doing 30, 60, 90 triangle for the special right triangle for the first one. So I'm just going to draw my reference triangle over here. And again, we have our label at 60, label at 30. And again, I'm going to go ahead and label this side opposite 30 my x, opposite 60 is x root 3, opposite this is going to be 2x. And so cosine of 60 is from the 60, we have the adjacent, which is x. Right, so it's like cosine 60 equals the adjacent over the hypotenuse, which is 2x. And again, these cancel, and we're just left with 1/2. So again, that one did give us 0.5. So that was good. But again, just looking at it and setting it up, we could have got it as well. Tan 30, though, again, you're always going to want to be precise. So this is why we actually draw the triangle, the reference triangle here. So if I actually, I'll keep that. Look at tan. Well, we know that tan 30, right, is going to be opposite over adjacent. So from the 30-degree angle, opposite is x over adjacent, which is x over 3. So we're going to have x root 3. And so the x's cancel, and we're left with 1 over root 3. Can't leave it like that. Got to rationalize the denominator, multiply top and bottom by root 3. So we end up just getting root 3 over 3. Now, root 3 over 3 as a decimal is this value over here, 0.57. But again, that's not exact, so we can get it exact. So with special right triangles, the ratios are exact, so we can get them that way. Sine 45 looks like we have to draw the other reference triangle here for the 45, 45, 90. Yeah, sure. So we have our 45, 45, 90. Of course, these are 45s here and here. Isosceles right triangle. So sine of a 45, doesn't matter which one we pick. it's opposite over hypotenuse, but again, at first I got to label my sides. So this was x, and this was x times root 2. So once we label them, sine 45 is going to be from this. Let's do the top 45. Opposite is x over hypotenuse, which is x root 2. Right, they cancel, so we get 1 over root 2. Rationalize, and so we're going to end up with root 2 over 2. All right, so we can get it exactly, and so we did. So we see that we can do that. All right, in this case is use your calculator to find each trig function ratio round to the nearest hundredth. This is a matter of plugging them into our calculator, so maybe we can do this pretty quickly here. I don't know how to clear this one. Hopefully it works just by doing this. Tan 67. What are we rounding to? The nearest hundredth, it says, 2 decimal places. So that's going to be 2.36. Sine 23. It makes me close out the parentheses. 0.39. Sine 49. 0.75. Okay, cosine 88 is 0.03. And this is actually, again, where making sure your calculator, your tan 45, again, is 1, because if it wasn't, all these would be wrong, and you wouldn't actually even know, because, yeah, you just wouldn't know unless you checked it. All right, so we have, what is that, 0.98, it looks like, if we round. And then tan 9, that says 8. So tan 9 is 0.16. All right, looks like we're good there. Not so bad. All right. Now we get to sort of solving each length here. So if we solve each length, all we have to do is make sure so we're trying to find BC, so I'm going to put an X there. And so what we're doing is we're saying, okay, from my angle, now I have this 23-degree angle, I might as well use it, right? So from here, we have, we're trying to find the opposite, right? If we're trying to find the opposite and I have the hypotenuse, I'm thinking, well, what one has opposite and hypotenuse together? And hopefully we see that that is actually sine. And again, I'm going to draw it up here again, just to have it on there. So when we look through them, so I know based on which angles or which sides that I have, which of the sine, cosine, or tangent, which of those trig functions that I needed to work with. So I'm going to set up the equation. I know that sine of the angle, which in this case is 23 degrees, has to equal the opposite, which is x, over the hypotenuse, which is 4. And then at this point, I'm solving for x, so I multiply both sides by 4. And we end up with x is 4 sine 23. Right, 4 sine 23. Remember, sine of 23 is sort of 1 unit here. And so this is sort of calculator ready form, ready to be input into the calculator. That's, that's a good solve right there. We just need to then plug it in. So our actual value when we're round to the nearest hundredth, and again, that's good to sort of see that as 4. Again, you can times if you want, but 4 times sine 23. Might have to do it in 2 steps on the calculator, but we have sine 23 and then times 4. So we end up with hundredth, we said, so 1.56, it looks like, 1.56, and that is rounded, okay? All right, so we do this middle one. It looks like we're trying to find QR, which is here. So that is opposite. We have adjacent. Opposite and adjacent is tangent. So we're going to say, all right, well, tan of the angle that I'm looking at, this 50, is going to give me the opposite over the adjacent. And again, it works the same way, and we can sort of see there's a bit of a pattern here. So we know that x is going to be, that doesn't look like x. X is going to be 8.1 times tan 50. And again, I can multiply this out, and we can do 8.1 times tan. Looks like I can do this in one step in here. Nice. 8.1 times tan 50, and that gives me 9.65. 9.65. And you can always get a good idea if it's way off or not. Like this is 8.1, this is 9.6. Yeah, they're close, and that's fine. If they're 45 and 45, they'd be even. So they're close to being even. In this case, this is the hypotenuse, so I know that if I found a value that was bigger than 4, I would know that it would be wrong. So that's a good sort of to look at and see. All right, looks like I am trying to find KL, which I think these need to be scrolling over a little bit. Zoom. All right, so KL is right here. And I'll go green here. So I'm from this angle here, the 61. It looks like I have the adjacent and the hypotenuse. So that's going to be cosine. So we have cosine of the 61-degree angle is going to be the adjacent over the hypotenuse. That's 2.5. Multiply both sides by 2.5. Looks like there's a bit of a theme here. And again, multiply by that whole thing. I'll show it like that. And so if we know that x is just going to be 2.5 times cosine 61, so 2.5 times cosine, oops, there backspace, yeah, there is 2.5 times, there you go, cosine 61, and bam, we get 1.21. Again, looking at the side, yep, it's less than that. We should be good. Oh, and again, the units, so that these are inches, these are meters, and those are centimeters. All right, so here we go. Looks like more of the ones from the top here. Righty's trig function is a fraction. Okay, so cosine, again, if we, just as a side note, if I looked at this triangle and we did not have this, right? If we did not have this right here, I could deal with this triangle. I could be like, okay, well, like if I was trying to write cosine, from D, I would need the adjacent 8 and the hypotenuse, which I don't know. I wouldn't put a variable here, right? I mean, because I can find out what it is. If you have a right triangle, you just do two sides of the you have two sides of the right triangle. You can find the missing third. This happens to be a triple, but if I did 8 squared plus 15 squared, I'd end up with 17. If I did square root of all that, 17 squared is what this is. So we have 8, 15, 17 is triple. So we found all the sides. Now that we know the sides, we can actually write all the fractions. Anyway, I went to it and it was 8 over, it was adjacent over hypotenuse, which is 8 over 17. All right, tan F, so that's opposite over adjacent. So that's going to be 8 over 15. Cosine F, that's going to be adjacent. So from this angle, right, from F, adjacent over hypotenuse, that's 15 over 17. I'll go back and do the decimals in a second. Sine D here, sine D is going to be opposite over hypotenuse. That's going to be 15 over 17, which again is the same. The cosine of one of those acute angles is going to be the sine of the other. And so sine of one is going to be the cosine of the other. So without really getting it, I can know that it's 8 over 17 because it's the same as this one. But if I looked at it, sine of F is opposite 8 over hypotenuse 17. And then tan D we know is going to be the reciprocal of tan F, the other angle there. So it's going to be 15 over 8, but just to double check, here's our angle D. Opposite is 15, adjacent is 8. So we're good there. And again, we can go back and do all these decimals here. So if we did 8 divided by 17, I guess we're rounding to the nearest hundredth as well. So 0.47, 0.47, which again is 8 over 17. So it's going to be this one as well. If I did 15 over 17, we get 0.88. So it's going to be 0.88. 15 over 17 is this one as well, 0.88. And I got 8 over 15, 8 divided by 15, which is 5 over that. And I had 15 divided by 8. So I might as well do both and then write them both down. So this is 1.88. And this one was 0.53. All right, so let's go to the next ones here. And I'm going to have to unzoom to get all these in. Okay, so let's take a look. We're trying to find this, and we're trying to round as necessary. So, okay, we're trying to find PQ. So there it is. All right, so we have the opposite. So from our reference angle, we have the opposite, and we're trying to find the hypotenuse. Opposite hypotenuse is sine. So we have sine of 19 has to be the opposite, x, over the hypotenuse, which is 11. And again, multiply both sides by 11. So x equals 11 times sine 19. 11 times sine 19. and it's 3.8. Makes sense. It looks like the short side. So 3.5, yep, 8. All right, do the same thing here. AC is this side, and now we get into one that's a little more tricky. It's just different from the other ones. Other ones will end up just being, because our numerator, our value was on the numerator that we're trying to find, our x was on the numerator, it wasn't as bad. But this one's a little different, so we will make sure to be careful. If we're trying to find AC, we have the adjacent, we want the hypotenuse, so we do know that's cosine still. The process is about the same, but it's cosine of 46 has to equal the adjacent 19.2 over the hypotenuse x. So the step is the same. I do multiply both sides by x. The problem now is that I have x times cosine 46. Remember, cosine 46 is just a decimal value. It's just a value. And so we have 19.2. And then I need to divide both sides by cosine 46. And so what we end up with is 19 divided by cosine 46. 19.2, that is. So that's what our value is. That would be our calculator ready form, would be that. And so if you'll notice what ended up happening at the beginning, like in my original function, my original equation, all I did is end up swapping these two values, the 19.2 and the cosine 46. So if you see that shortcut, you can write it out once and then just swap them, and it ends up being the same thing. That's just how the algebra works out every time. So if I did 19.2 and then divided by cosine 46, and it's 28.64, 28.64, that says 2, 6, 4. Okay, 28.64. You know what? I'm going to make that look better. And that was an eraser. There we go. Better. All right. 28. Point. Oh man, different color. All right, didn't look better. I lied. We'll do inches there, centimeters there, and we'll do this next one in blue, just for fun. Okay, so all right, so good. And again, it's about in the right. It's bigger than that because it's the hypotenuse, so we're on the right track. All right, so from this angle here, we have the opposite. I need to find GH, which is the hypotenuse, so opposite over hypotenuse. So it's going to be sine. So sine of 34 equals the opposite, 11, over the hypotenuse x. This ends up, remember, doing the same thing when we see that we would have to multiply and then divide. If I just swap them, right, and say, or swap, like, I didn't mean swap these two. Like you swap the x and the cosine 46. So in this case, we're swapping the x and the sine 34. So it ends up just being x equals 11 over sine 34. Pardon me, last time. We got the same way. I just said it wrong. Okay, so we would have 11 divided by sine 34. And then we get 19.67. Makes sense. It should be bigger than 11. Yeah, 19.67. And that is feet. Okay, so we keep on going. We got these three left. XZ is the hypotenuse. So, and we're trying to find the hypotenuse. We have adjacent, that's cosine. Cosine of 25 equals the opposite, or sorry, adjacent, which is 33, over x, which is our hypotenuse. We swap those two. X equals 33 divided by cosine 25. And then x equals, let's see, it was 33 divided by cosine 25. Much easier when you're not clicking. 36.41, 36.41 makes sense. Bigger than that one. Awesome. All right, so KL is right here. Here's our angle. It's adjacent over, opposite over adjacent. That's going to be tangent. So we have tan of 61 equals the opposite over the adjacent. And again, same thing. I'd multiply by x, divide by tan 61, but essentially gets me to the same place where x equals 9.5 over tan 61. And so we get to do that on our calculator now. We are allowed to. It's great. Good times. Tan 61. Boom. And again, 5.26, 5.27. And that is feet. And that is inches over there. All right. And then we have trying to find EF, which is this. that's opposite, and adjacent, that is tan again. So tan of 12 equals x over 83.1. And so we do have to just multiply both sides by 83.1. So x equals 83.1 times tan 12. So 83.1 tan 12. 17.67. Yeah, it looks shorter than that one. Yeah. And that is meters. All right, so there we go. Hopefully I didn't make any mistakes. If I did, put them in the comments or something. I don't know. Let me know. All right, thanks.